Problem 8. Malcolm wants to visit Isabella after school today and knows the street where she lives but doesn't know her house number. She tells him, my house number has 2 digits. Alright, so let's write that down, 2 digits. And exactly 3 of the following 4 statements are true. It is prime, it is even, it is divisible by 7, one of its digit is 9. The information allows Malcolm to determine Isabella's house number. What is its unit digit? Well, what is the first thing that stands out? It's the prime term, right? A prime number is only divisible by itself and 1. So in other words, if it's a prime, it cannot be divisible by 7, and it cannot be even, right? So that means, if, for example, well, let's just do process elimination here, right, with this understanding. Let's say this is false, right? If this is false, that means the rest must be true. But can a number be prime and even at the same time? Well, no, right? If it's even, it has to not be prime, because evens, by definition, have a term of 2, right? And it's a 2-digit number here. So that means if I had just 2, that would work, but it's a 2-digit number. So I have to have, a number that's not prime if it's even. So that means this here, right, can't be false. This has to be true. What about one of its digits? It's 9. Well, I can't really determine that right now. Let's assume, right, the even part is false. If the even part is false, the rest are true. Well, would that make sense? Its prime is divisible by 7. Well, that can't be true, right? Because if it's divisible by 7, then it's not prime. The prime number can only be divisible by itself, like, for example, 13, right? It cannot be divisible by 7. So in other words, the second statement where it's even, right, has to be a true statement. So this has to be a true statement. So it's either the prime or the first term, or it's either the first statement or the fourth statement that are incorrect. Let's assume that the first statement is false, right? If the first statement is false, that means this has to be true. One of its digits is 9. If it's one of its digits is 9 and it's divisible by 7 and it's even, can that work? Well, let's think about it. What is the least digit? What is the least multiple of 7 that has 2 digits? Well, that's 7 times 2, right? That gives 14. And then we can go all the way down until 7 times what? 99 divided by 7. What is that? Well, that's 7, 29, and 4. So we can do 14 times 7, which gives 98, right? So all the way until 98, we can have these possible terms. So one of its digit is 9. How many of the multiples are 9? Well, 7 times 2, right? We have 7 times 3, 7 times 4, 7 times 5, 7 times 6, 7 times 7. That's the only thing that comes to mind. 7 times 7 is 49. 7 times 8, 7 times 9, 7 times 10, right? 7 times 11, 7 times 12, no. 7 times 13, no. And 7 times 14. Okay, so the only possible terms are 98 and 49. Would that work? One of its digit is 9, checks out. It's divisible by 7, checks out. It's even, checks out. And the only term here is 98. So that means if 1 were false, then 98 would be a plausible solution. Therefore, the unit digit must be 8. Therefore, your final answer will be answer choice D.